Are you with me?
Right. Yep.
I don't see Mirzayan's with me. Mirzayan, you with me? Okay, we're going to graph this. So we're going to use brute force because I don't know how to graph it. And by the way, we're going to graph it that way for all of these. Brute force. Theta R. Oh, yeah. Right here it says it's in degrees, so we're going to go degrees, right? So 0 degrees, 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150 degrees, 180 degrees, 210 degrees, 240 degrees, 270 degrees, 300 degrees, 330 degrees, 360 degrees, 390 degrees. With me so far? With me so far, Mr. Zion? Come on, plug a 0 in here. 0. 2 times 0 is? 2 times 0 is? Zion?
Sorry, what did you say?
2 times 0? 0. Cosine of 0? 1. 1 times 2? 2. Love it. 30 degrees. 2 times 30 degrees is?
2 times 30 degrees. What? I'm so sorry.
I'm putting the angles in here where it says angle, right? So I put a 30 right here. What's 2 times 30? Cosine of 60. I don't think she's answering that question. It's 1/2. 2 times 1/2 is? Thank you. Okay, I'm going to smooth somebody else. Mr. Sussman, 60 degrees. 2 times 60 degrees?
120.
120 degrees. Cosine of 120 is also 60 degrees reference angle, so that's 1/2.
-1.
But it's in the second quadrant, so it's negative. So negative 1/2 times 2 is?
-1.
-1. I love it. Now I'm going to move forward. Do 90 degrees. 2 times 90 degrees is 180. Cosine of 180 is -1. 2 times -1 is -2. 120 degrees. 2 times 120 degrees is 240 degrees. 240 degrees, cosine of 240 degrees, 60 degrees in that quadrant, which is also negative. So -1/2. So it becomes -1. Okay, Mr. Green, you with us?
Yeah.
Okay, put a 150 in there. 2 times 150, Mr. Green.
300.
300, cosine of 300.
So the cosine of 300 is going to be 60 degrees in your fourth quadrant. So it would be 60 degrees that way. This would be 1/2, right?
1/2. It's in the fourth quadrant, so it's positive. 1/2 times 2 is?
1.
180 degrees. 2 times 180? Yeah.
Okay, 360.
360, cosine of 360.
1.
1. 1 times 2?
2.
2. I love it. Okay, so I'm going to stop temporarily putting up numbers. We're going to see what we got so far. Is that okay with you?
Very.
All right. Now the first point we've got is at 0 degrees, we're at 2. Love it. At 30 degrees, we're already at 1, falling inward. At 60 degrees, we're at -1. So 60 degrees is normally this way, but we're at -1. It puts us here. Now I'm a little confused. What happened there? Right? I can kind of follow this, but what the heck happened there? Mr. Cassini, do you have a solution for this? How can I figure out what happened in the middle between 30 degrees and 60 degrees?
Maybe just keep graphing points.
Let's graph 45, shall we? Temporary break. We're going to go over here 45 degrees. 2 times 45 degrees is what, Mr. Cassini? 90 degrees. Cosine of 90? 0. 2 times 0? 0. So 45 degrees gives me 0. So in between, I have a 0. I guess that clarifies my point. I guess I'm doing this. What am I doing? I'm going to go out to the next point. 60 degrees is -1. We did that. 90 degrees. We're at -2. Where does that put me, Mr. Sussman?
90 degrees, so
Negative 2.
sine of 180.
Wouldn't it be 270? Instead of going 90 this way, I'm going to walk the opposite way too, right?
Yeah.
There you go. All right. Woo! Okay, at 120, I'm at negative 1. 120, I'm at negative 1. That puts me here. At 150, I'm at 1. Guess I'm going through the middle again. Whee! At 180, I'm at 2. What the heck am I drawing? Like a drawing class for Klingons or something. Here we go. Keep going. 210. Who's got 210 for me? 210. 420. 420 is 360. It's 60 degrees, isn't it? Resign, you're collapsing under the pressure. 60 degrees. 60 degrees is negative 1. We already did this one, negative 1. So at, well, that couldn't be right. Oh, 210 is 420. 420 is 360. Is that right?
Yeah,
Should be a positive one. I'm with you. Why is it not a positive one? It should be a positive one with you. Why is it not a positive one? Why am I not getting a positive one? Did I skip something?
I got positive.
Positive 1. 210, 420. 420 is, oh, because I already did the multiply by 2, so it's more like 30. Okay, 60 degrees comes out of 60 degrees is 1/2. 1/2 of 2 is a positive 1. So it'd be right here. So my flower is coming back. Love it. Then I might do 240, and I realize I've got a pattern here. 2, 1, negative 1, negative 2, negative 1, 1, 2, 1,
Negative 1.
negative 1. So at 240, I'm out here. I'm drawing my pattern out that way. So far, so good. I do my next one. I go, okay, I've got this figured out. Next one should be negative 2, right? So at 270, I'll be negative 2. That puts me here. At 300, I'd be at negative 1 again, right? 300 is this way, so negative 1 puts me there. Great. And then next I'm back to positive 1, which puts me right here. Back to the center. And back there at 360. What have I drawn? I've drawn a flower. Technically, this is not a flower. This is a rose.
What?
What? Flower, petals, what do you mean? Actually, I don't mean anything like that. I mean, this is what we call a rose in math class. It's an official term.
Oh my god.
No matter how many petals it has, we call it a rose. We got names for other types of graphs that look sort of like this, and let me go through them now, because one of the problems with doing graphs like this is you have to know when to stop. What do you mean by that? I mean, you got to know when you've got the picture right. Does that make sense? So you don't have to do every single dot and get tired. So what are my choices? The answers are there are several classical curves. You've just seen the first one, a rose. A rose looks something like this. I always get this wrong. You go, wee, 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 wee. It could have 3 petals, 4 petals, 5 petals. They're all symmetric when you do that. Fair enough? This is called a rose. Second type is a lemniscute. Lemniscute. This is French. Lemniscute. Lemniscute looks like this. Lemniscute. Lemniscute. Then the next one is called a cardioid. What is a cardioid? Oh yeah. Oh yeah. It's heart-shaped. Cardioid. It looks more like a bean to me too, but they call it heart-shaped, cardioid. That's what cardioid means.
Where's the like center?
It could be here.
It's more like a.
And then last but not least is the most dangerous of them all, les maçons. Limassol. Limassol looks like this. It's a cardiac with a loop in the middle. Oh, that makes it dangerous. There's also one that was invented by a Greek fella, so we decided to name it after him. It's called the Spiral of Archimedes. Looks like this. And so forth.
Where's this center on
It could be anywhere, but likely is right about there.
Is that like infinite?
Yep. All right, those are my choices. Are you ready for graphing fun? I'm going to go take a nap.
No.
Turning the page.
No.
1 through 6 are waiting for you. Nap time's waiting for Mr. Resney.
Here's the
I'm gonna